Assalamualaikum, sir. Today, I'm going to highlight about a lurking concern of every member of every household of Dhaka City. It is home burglary. Nowadays, unfortunately, whenever we turn on to the news channel, we will find at least one instance of home burglary. To address this problem, we, the members of Group 2, have come up with a unique solution called Smart Home Security System. This project was collaborated by the following members: Tazwar Siddiq, me, Raunak Tanzim, and Asaduzzaman Shubho. Now, what is smart home security? This system is entirely based on the concept of finite state machine. Finite state machine includes a set of inputs, a set of outputs, and a set of different states. Now, let me brief you about the benefits of our system. First of all, our surveillance will be improved. We can get instant response. And finally, the most significant benefit is we will be able to deter any mischievous activities from taking place. Now, let's discuss how our project will work. The first state of our system is disarmed. After activating our system, it will get armed. Suppose an intruder tries to barge in to our house. At this case, our alarm system will start ringing, and after a certain delay, if the alarm system is not turned off, a call will be placed on to the emergency services, and they will get notified about an intruder trying to barge in into a house nearby. Now, the remaining segment will be discussed by Asaduzzaman Shubho.
Assalamu alaikum. Myself, Asaduzzaman Shubho. Today I present you a marvel of modern engineering and intelligent home security system encapsulated in code. Imagine your house as a fortress and this code as the guardian of its defenses. At its core, we have a finite state machine. The states disarmed, armed, alarm, and emergency service mirror the dynamic nature of home security. As the clock ticks and events unfold, our system transition seamlessly between these states. First of all, we declare two input as active and unauthorized entry along with clock and reset. We have two output here, alarm output and call output. We declare the parameter for our states. The first always block is for clock and reset. The second always block show the seamless transition between the states. And the last always block show the output of these states in our intelligent home security system. Test-bench code convert a virtual playground for our smart home security system. It's like a trail run, making sure our digital guard knows its moves. It's a simple story told through the language of ones and zeros. First of all, we create a clock that ticks every 5 minutes of time. We connect it to the virtual or with the design code. Firstly, we declare the input as a register and the output as where, and shows in test-bench stimulus the different condition for our input to test our smart home security system. And lastly, we declare a dump web blocks to show the output as a waveform.
Assalamu alaikum, sir. My name is Tazwar Siddiq. My role is 2021160095, and I will be presenting the next stages of our project. Here we can find the results of our simulation. So we have given a clock cycle over here, and the reset has been turned low in the first clock cycle. So we can see the inputs activate an unauthorized entry in these two segments. These inputs have been selected using the test bench code. And the two outputs, alarm output and call output, are here. If we can look clearly, in the third clock cycle, an activate signal was given. This states that we have transitioned from our first state, which is disarmed, to our second state, which is armed. So we keep in this state until the activate signal becomes low. So now we go back to our first state. Again, in the 8th clock cycle, another activate signal has been given by the home user. This keeps going until in the 10th cycle, an unauthorized entry signal has been detected by the system. Because of this, an alarm output has been seen by the system. So this signifies that we have transitioned from our second state, which is armed, to our third state, which is alarm. So this means that the alarm has now risen and is ringing. However, before a call can be made to the authorities, the system was deactivated, which means that the appropriate password was given to the system. Again, in the next few clock cycles, activate signal was given and intrusion was detected. And similarly as before, alarm was seen over here. However, here, if we look closely in the activate signal, this time there was no deactivation in the system, which is why in the next clock cycle, the call output signal has been seen as high. Now, this signifies that we have transitioned from our third state, which is alarm, to our fourth state, which is emergency services. Now, this means that a call will be placed to the relevant authorities for apprehending the burglars. So that basically wraps up our project, and I will be giving a brief summary of what we have learned. This project demonstrates the potential of finite state machines in designing and implementing efficient and reliable digital circuits for many applications. In this system, we have shown intruder detection, alarm trigger, and instant response, thereby fully automating the security process. As a result, home security has been made easy, efficient, and reliable. Moreover, we are also hoping to, in the future, to explore the expansion of this system to integrate additional features such as remote monitoring and biometric identification to further enhance our security and make this project even greater. So basically, I just want to thank Sir on behalf of myself and my team members for giving us this opportunity.